All right, so we're in chapter 4 on analyzing change, applications of derivatives. Now this is section 4.6 on optimization of constructed functions. So models can be constructed directly from verbal descriptions instead of tables of data like we've been doing. Now, as long as the mathematical functions constructed are continuous, the optimization technique that we've discussed in sections 4.3 through 4.5 still holds. So, derivatives, setting equal to 0, all kinds of stuff. Everything holds once we get that continuous function created from the verbal instructions. Now, the hardest part of this section really is going to be setting up the model to be able to solve. So, really, this first part here is going to be kind of explaining how to set it up and things like that. And then when you get to the point where you have to solve it, we know how to do that already. So the problem solving strategy for optimization. First step is to identify the quantity to be optimized, which is basically our output, and then the quantities on which the output quantity depends, which is going to be our input. Then we sketch and label a diagram of the situation described. Now, the thing here is this second step might not actually be done. If you're doing something that doesn't need to have a diagram or can't draw a diagram, then you can kind of skip step 2. Now, step 3 says construct a model with a single input variable. So you're going to get a thing. You might have maybe the area is equal to x times y, and maybe you have a perimeter is equal to 2x plus y. Maybe you have one side as a house or something. And what you're going to do is you're going to solve this one because you might know the perimeter, maybe it's 50. You'll solve this one for y, and then you'll plug whatever that is into this one. And so we have just one function in one variable. Okay, that's what that means by constructing a model with a single input variable. And then step 4, we're going to locate the optimal point for the model. Okay, so then that's when we kind of are working on solving it. So kind of going through each of those in a little bit more detail. So variables and verbal descriptions. So this is our step 1. So to construct a model from a verbal description, we need to identify the quantity to be maximized or minimized, which is our output variable, and the quantity or quantities of which the output quantity depends. Basically, what are our input variable or variables? Now, this information is found usually in the very final sentence of the problem statement. Not always, but almost every one of them, this is where it's at. And step 2, we give sketches. All right, so then we sketch a diagram of the problem if it's geometric in nature. That is, if the problem involves constructing containers, laying cable or wire, building enclosures, patios, or any of those things, you can draw a diagram. Now, it doesn't have to be elaborate. Basically, okay, I'm going to have a house is going to be over here, and then I'm going to make a porch here. Okay. And I need to have this side and I need to have this side. So, that's about as elaborate as it can be in this case. And so, we need to find out the length here and the width here, or however you want to look at it. And and the key thing is this actually might be longer and this might be shorter depending on when you get done with the calculation, what your x's and y's are. And then what we have to do is we just label it and then we just follow the problem based on our labeling. And then whatever answers we get out, we'll get some x is equal to whatever and y is equal to whatever. Maybe we maximized it for the area of this area. Maybe we did it to have the perimeter a certain way to get the cheapest cost of fencing or something. But that's what we're going to do. And so we label all the pieces, and and then at least one of the variables has to represent the input quantity in the problem. So in this case, we probably have two of them, but we're going to make it go down to one. So we have that. And then after that, we can plug it into the other one at the very end and solve for this second variable. Now, step 3 is constructing our model. Again, this is going to be the hardest part. Usually drawing the picture, trying to figure out what that optimization part is and the input and outputs, those two things, those aren't too bad. Constructing the model sometimes takes a little bit of thinking. Sometimes you'll work it down and try to think about what you need to do, and you'll get to the point where like, that doesn't work, but if I do this instead, this works. So this is probably going to be the one that takes the most time for you, and probably the most frustrating as well. So constructing the model is the most important step in optimizing the problem that are given in verbal form. This third step is broken down into 3 phases. First, we're going to identify the connections between the output variable and the input quantities, and we're going to express the output quantity as a function of the input quantities, okay? And sometimes you're going to have to look up formulas. Maybe if you don't remember a distance formula, a distance between 2 points, maybe you have to figure out what that is. So you're going to do that kind of lookup. Maybe you forget, the Pythagorean theorem, or, there's lots of different things, and you might not remember exactly what it is. And so you have to figure those out and then plug them in. Then we're going to identify the connections among the input variables. So if there's more than one input variable, we're going to decide which single variable to use as the input for the model. All the other input variables then have to be expressed as functions of that one input variable. Now, this step may require the use of secondary equations that relate the input variables in that one equation. And then we're going to rewrite the equation as a function of only one variable if it's not already in that form when we get done with step 2. And then we're going to consider that our input interval. And then step 4, that's the fun part, that's the optimization. So after a model with a single input variable is formed, the process of optimization is no different, like they said, between section 4.3 and 4.4. And so, we're going to probably take some derivatives, we're going to set some stuff equal to 0, we're going to solve for x, and then we're going to plug back into the problem and get other things. And so it's just going to be a matter of going backwards once we get to that point there. All right, so at this point, I'm going to stop, and then we're going to start the problems, and each problem will take, a little bit of time, so we're not going to do but one at a time.